Well, hi there folks. Welcome along to the last session of the afternoon. It's great to see so many folks here, especially when I know that I'm all that's stopping, or basically all that's in between you and a couple of beers tonight. So thanks for coming along. So folks, it's getting a bit late in the afternoon, so I don't know about you guys, but I'm feeling a little bit tired, so I'm going to get everyone in the room to stand up. I'm going to get everyone in the room to stand up. I'm going to get everyone just to pop their hands up in the air. We're just going to have a bit of a stretch. Going to pop the other arm behind, and then the other one. Let's put our arms behind, and let's shake it all out. Doesn't that feel fantastic now? I'll get you guys all to sit down. So this afternoon's session is, I'm a DBA, why should I care about SQL Server 2008 R2? Now, where this session actually came from is from talking to a number of our customers. One of the things that they said time and time again to us is, I'm a DBA. Why should I care about R2? Like, I'm not a BI guy. I'm not into this whole Power Pivot stuff. I think it's great and fantastic. I love what's been done with the spatial features inside of reporting services, but I'm an infrastructure guy. What's in it for me? Why would I go and invest the time and effort to go and upgrade all of my SQL infrastructure when my business is not mature enough or in a position to go and take advantage of a number of the BI features? So that's really what this presentation's about, is really how do we go about finding what those features are, and really what's the value proposition in order for us to then go and upgrade to R2. So what we're going to cover in today's session here, so quick introduction. I think most of you have done the SQL tracks, have seen me, but Peter Ward, Chief Technical Architect for Wardy IT Solutions, based over in Brisbane. I'm an MVP and also a virtual TSP for Microsoft as well. But really, what are we going to cover today? Well, really what we're going to have a look at is we're going to have a look at what's new in R2, but then what we're going to do after that is we're really going to lift up the hood, and we're going to have a look a little bit deeper into some of the internals and some of the things that have really significantly changed that's really started to make SQL R2 an even more scalable database than what we had with 2008. So a number of those features have come about because of customer requests and the ability for SQL to really start to scale up to those multi-terabyte sizes. So that's what we're going to have a look at today. So what's new? So folks, does anyone want to share with me where they would go and look to go and find out what's new in SQL Server? So where would you go to look? TechNet? Someone whisper MSDN over there? Well, the first place that I would normally go is I'd go to my good friend Books Online. I'd fire up Books Online and I'd try and have a look at what I could find there. But really, it's like trying to find a needle in a haystack, because when I go and open up Books Online, I get flooded with all of these great features that we've got in R2, such as Power Pivot and all of the BI functionality. So let's go and fire up Books Online and see what we can find. So I've got Books Online here, and you'll see that I've gone to the contents and what's new. And when we have a look at what's new, you'll see that we've got Power Pivot for SharePoint, Power Pivot for Excel, it must be good, it's listed twice. We've then got multi-server management, master data services, and then we've got features supported by Edition. The fact that SQL Server Express Edition now supports a 10 gig database size has made it to the feature list there. But where's that stuff that gets me excited as an infrastructure DBA from a performance tuning perspective and the things under the hood? Well, maybe I need to go and have a look at what's inside of the data editions here. So if I was to scroll down a little bit here, what you'll see is I can come down and you'll see, not a lot at all. Not a lot at all. So I've got the database engine, I could click on here, have a look at what's inside of the database engine. Oh, availability enhancements, oh, that sounds pretty exciting. Let's click on it. What we'll see here is for R2, there have been no changes for the content that's listed in this topic. So where am I going to find all of these features? And look, when I started talking to customers, that's the first thing that I did. I went to Books Online. What's there? It's very, very hard to find. It's like trying to find a needle in the haystack. So multi-server management is obviously one of the key features, and we're going to take a look at that, because multi-server management really goes and solves a number of the challenges that I have today inside of my environment. So when we look at what's new for a DBA, once I've gone and peeled back all of the layers of the onion, we've really got 5 main new features that we've got inside of R2. Now the first one we've got up here is our SQL Server utility. Our SQL Server utility allows us to holistically take a view of all of the SQL Server instances that we've got inside of our environment and get a central dashboard for all of these. We've got our data tier applications, which is a paradigm shift about the way that we go and deploy database applications. It now allows us to go and encapsulate all of the changes in the entire database, so everything from that schema level as well as the dependency as one package that we can deploy from one server to another. We've also got connectivity directly to Azure, meaning that we can go and use Management Studio, which we know and love, to manage both the databases that we have on-premise or off-premise, or also directly up in the cloud as well. We've also got improvements that we've made around the PowerShell provider, and then we've also got support for Unicode compression as well. So compression was first introduced in SQL 2008. We've now built and extended that capability to now include Unicode. So previously, if we had Unicode data, we weren't compressing that. And we'll take a look at a demo a little bit later about why that's so important to us. But I want you to think about your own organisation. We've got a number of challenges that we face. And from talking to people around drinks last night, one of the common things that came up time and time again is what seems to be a catchphrase in the organisation, and that's how do I go about doing more with less? In other words, the number of databases that we need to support as DBAs continues to increase. What also is increasing is the power of the computing power that we have that's available to run these databases on. Now, I want you just maybe to cast your mind back a little bit about the way that organisations ran about 20 years ago. For some of you that have a little bit more grey hair than me, you might be able to remember back 20 years in the workplace. But for those that aren't familiar, basically what would happen in the workplace is we'd have a big long row of tables, very much like being at school or at university. We'd have an in tray and then we'd have an out tray. We'd then have somebody in a trolley that would then walk from one end of the building to the other, taking things out of somebody's out tray and putting that out tray into somebody else's in tray. In other words, it's a very manual business process. In our organisations today, these business processes are now being replaced by software. We've got things such as an ERP system, a payroll system, a HR system. So all of these different systems that are designed to streamline business process. The challenge though is as soon as I introduce a new application inside of my environment, I also bring another database as well. Because there's very few line of business applications that don't have a database sitting behind them somewhere. So what's happening is the number of databases as DBAs that we have to support is increasing. However, our headcount from a DBA perspective is actually typically decreasing in most organisations. So what's happening, especially over the last 2 years, is there's been a lot of attrition in a number of organisations. So as a DBA's left, that person hasn't been replaced, or as more workload has come on board, we simply have an increased headcount. So I was reading an interesting article actually by the Forrester Group recently, which is basically like a Gartner. They do a lot of surveys about what's happening in the industry. And they were saying that the average SQL DBA today supports about 86 databases, and that's growing at about 12.5% per year. Now personally, I actually think that number is actually a little bit low, 86 databases to support, based on the number of organisations that we've been talking to. But remember, that goes all the way from the person that supports one database to the person that supports hundreds of databases and everything in between, hence the average. So we've been asked to do more with less. So really, how can we go and do more with less? Well, that's what R2 has brought to the table. There's a number of new technologies that have been brought forward in R2 that really empowers us as DBAs to solve some of the common pain points that we come up day in, day out. So the first thing that we've got really, and it's really this whole management challenge. And when we talk about this management challenge, this is really what Microsoft looked at when they were making a number of these new features, is what are the challenges that we have? Well, the challenge is really at the moment it's very hard for us to go and get an enterprise view of all of the SQL Server instances that we have. So we've got versions from SQL 7 potentially up to 2008 R2, Enterprise, Standard Edition. We've got some on this site, we've got some on another site. How do we get that holistic view of all of those servers inside of the organisation? So really being able to tell, are those servers running optimally or aren't they running optimally? The other thing that we don't have though is really the ability to look at an individual application. Now it's very easy for us to determine at the server level what's going on. There's a number of tools that allow us to do that today. In fact, we can easily go down to the database level and actually determine, okay, is that database running optimally? The challenge is though often in a database we've got multiple applications connecting to that one database. We might go and have the transaction processing system connecting to there. Then we might have a reporting services report that's hanging off exactly that same database. It's been very hard for us to isolate on an application by application level where that performance bottleneck is really occurring. The other challenge that we've got really is around resource or capacity planning inside of our organisation. So how do we actually then monitor the growth and the utilisation of all of the SQL Server instances we have? So they're the challenges that we have. And this is where the tools inside of R2 come into play. Now the first challenge we want to talk about is this whole concept of developers versus DBAs. Now we all know developers smell a little bit, so typically what we do with a developer is we go and put them in the furthest corner away from a DBA, and the two never shall talk to each other. The only time that a DBA and a developer talks to each other is typically on that day of release, when all of a sudden what the developer does is it grabs that hand grenade, lobs it over the fence to the DBA and says, DBA, can you please go and promote this into the environment? The DBA doesn't have an opportunity often to perform any governance or testing on that. They just get given a SQL script and they're expected just to run that SQL script. Inside of that SQL script's probably all sorts of nasty little things like drop tables and things like that. But one of the things that really annoys me is the fact that developers seem to forget that they need to use the use statement. So we run the script and we get objects sitting inside of our master database. So the problem is from a developer's perspective, developing is easy and deployment of a new application is simple. I simply grab an executable and I then go and throw that over the existing executable. The problem is as a DBA, and as we know, we need to manage the data that's sitting inside of that table. So how do we handle things such as upgrades or which is even harder, how do we actually reverse out and back out that change? So how do we do an uninstall in effect on a promotion that we've done from a SQL script? Now the other challenge that we've got is really around visibility and how do we get access to everything. And this is where there's two new features, the first being the SQL Server utility and the second being our data tier application. Now both of these actually work hand in hand because what the SQL Server utility does is it provides us the ability to then go and look at the entire health of our SQL instance. We can look at things such as CPU, we can drill down and go and see growth over time, not just of the database but also of the individual files and file groups inside of that database. And what it allows us to do is it allows us to enroll an application. So what that means is I can then go and monitor the performance utilization of that particular application. So in effect, not only do I get to see the server statistics or the database statistics, I also get to see the individual application statistics as well. And where this starts to become interesting is all of a sudden I can do internal chargebacks. So I know the entire utilization of my server. I then go and know the utilization of each application. I know which business units use that application. So hey presto, I can now carve up that cost for that server and then charge that back very accurately to those business units. So we're actually now paying upon utilization rather than guessing on what the cost of that management of that server for a particular business unit is. Now, what is this whole utility control point? Well, really this utility control point is the central server that's sitting somewhere in my topology. This central server inside of my topology then goes and monitors other servers inside of my topology. Very similar to maybe if you've used some of the master and target servers, where I can use a central server to then go and monitor all of the jobs and whether they've run successfully across all the other servers in my topology. But what this allows us to do is it builds on top of the management data warehouse that was introduced in SQL 2008. So what we've got is a number of collectors of information that we're now pulling back to this central location. And then what we get is we then go and get this central utility dashboard that allows us to see holistically across all of our sites. Now the way that we go about creating a UCP is the first thing we need to go and is create one. So we create one of those servers somewhere inside of my topology. We then need to go and enroll all of the SQL Server instances we're then going to manage. So these are all the servers that we're monitoring. What we then do is we then go and enroll any applications that we want to monitor at that particular application level. And then what we do is we go and use SQL Server Management Studio to then go and monitor all of this. Because what we've now got is a new utility explorer that's been added inside of Management Studio that allows us to dive in and find out what's going on. And then finally we get to go and customize all of our policies. Because where we're really going with this technology is if anybody's worked with any of the virtualization technologies, it doesn't matter whether you're using Hyper-V or whether you're using another vendor. Really, what we're talking about is how do we get the maximum utilization out of our hardware investment. So we've got the whole concept of something being overutilized, something being well utilized, and something being underutilized. And this is exactly the same way that we now want to manage all of our SQL instances as well. So we want to actually consolidate those and get the maximum bang for buck out of our hardware. In other words, we want to start to actually take all of these servers that might have been sitting at 10 to 20% CPU, and we now want to get them at something maybe about 50 to 60% CPU. But look, as a DBA, I don't know if I'm necessarily comfortable of going straight to 50 to 60% CPU utilization. In fact, the out-of-the-box policy with Utility Explorer is that up to 70%, I actually don't consider that to be an issue. It's only when CPU utilization gets above 70% do I then consider that to be an issue and above threshold. So we've got the ability to customize all of these policies. And an analogy that I use around all of this when we're talking to DBAs about performance utilization is my wife who laughs at me because I'm looking at you go through that midlife crisis, and I sort of said to her, look, we haven't got the family, wouldn't it be great to go and get a Porsche 911 GT Carrera? And she goes to me and looks at me and goes, look, you're just going through that midlife crisis, just get over it. And look, I don't know if I'd necessarily be comfortable driving the Porsche at 360 kilometres an hour, which is its maximum road speed. But I reckon I'd give it a red hot crack at about 250 kilometres an hour. Now, what I can know is because I've got that additional threshold, I've then got that additional capacity. So if I was to get in trouble, I can then go and, drop the accelerator down and get out of whatever position that I'm actually in. And that's exactly what we want to do with our servers, is we want to push that utilization up, but we don't want to make that to an uncomfortable position. We want to know that we've still got that ceiling level. But with our policies, if we're not comfortable, we can go and define what our own policies are. So our data tier applications. So quick straw poll. If we were going to go and deploy an application from pre-prod to prod, and we needed to go and make some schema changes, who here'd go and right-click and script the changes? No? Who would maybe go and use something like Data Dude, so Visual Studio Team Edition for database professionals? And the rest of you guys obviously aren't deploying changes from pre-prod to production. Does anyone want to share with me what they might be using, what methodology or process? Sorry? Yep, DB Ghost. Okay. So one of the challenges is if I go and right-click and script all of the objects in the database, what don't I get? Well, what I don't get is I don't get all of those artifacts that are external to the database. So if I go and right-click and script the database, I get the database users. What don't I get? I don't get the server logins. So what that means is if I go and take that script from server 1, run it on server 2, that's all well and good, but those artifacts external to the database, such as server logins, haven't been taken across. So with our data tier applications, also known as our DAC pack, because that's the extension of the file that gets created, is what we can now do is capture those artifacts that we have a dependency on that aren't necessarily inside of the database. So I can right-click and script my database and collect those artifacts. What our DAC pack allows us to do is encapsulate them in one file. So basically it's like a zip file, and it contains all of the dependencies that's required, not just the SQL script. But the other thing that the DAC pack allows us to do is define a policy. So that policy means that I can prevent somebody from running this script on a platform that's not supported. So for example, if the target deployment environment for this is requiring Swahili collation, or maybe I'm dependent on a particular service pack, I can make all of those checks, and if those checks haven't been met, what will happen is I'll actually not allow this script or allow this DAC pack to actually get deployed. The other thing with using the DAC pack is it simplifies the whole end-to-end deployment process. So rather than having to run a script, I've got this whole concept of upgrade and then uninstalling of my SQL Server changes as well. So let's have a look at how the utility control point works, as well as also a DAC pack. So what I've got here is I've got two SQL Server 2008 R2 instances running here. What I'm going to do first is I'm going to create my UCP, so my utility control point. In order to do that, I click on View, and you'll see that I now have this Utility Explorer here. So when I click on Utility Explorer, it then comes up with a configuration wizard. What it also comes up with a number of videos that I can sit down and watch and then learn how to go and create this UCP. But look, what I'm going to do here is I'm just going to run through the wizard to create my UCP. What you'll see here is that I then go walk through step by step. Now the first thing that I get to decide here is what is the SQL instance. So in other words, what instance am I going to run my UCP on? So this is the central server that I'm going to use for all of my monitoring inside of the topology. In this case, what I'm going to do is just use my local host here. What I'm then going to do is I'm just going to go and leave my named utility control point here called UCP. So let's just come back to that. Okay, so just click on Next. What you'll see here is I then need to specify an account. Now this account that I'm specifying is the account that needs to be able to have permissions to go and connect to all of those other servers inside of my topology. So if we've got multiple domains, we then need a trust between those two domains in order to connect across them. In this particular scenario, what I'm going to use the SQL Server Agent Service account. That service account is already running under the domain account. What you'll see is we go and then do some pre-validation checks. So these validation checks allow us to then make sure that everything's been satisfied before we get to the end. Because there's nothing worse than clicking through a wizard of 9 screens, getting to the end and failing at that particular point in time, hence the pre-validation. So you see that we've passed everything okay. I then go and click on Next. So what you'll see here is we go and create our UCP. As we said, we're building that directly on top of the management data warehouse, and then what we're doing is then we're going to enroll the UCP. So when we go and create a utility control point, we also then go and monitor ourselves as well. So it just takes a couple of seconds to just go and enroll that UCP. So now we're going to click on Finish. So what you'll see now is here's our central server utility. This allows us to then go and see all of the servers that I've got into my topology and then all the different metrics about them. So what you'll see is that we've got our standard traffic light scenario up there where red is bad, green is good. So what you'll see there is that when a server is being overutilized, it's red. When the server is being well utilized, it's green. Underutilized, it's just a lighter shade of green. Now you'll notice at the moment that this is coloured blue. And the reason it's coloured blue is that we haven't gone and captured any information yet. So what happens is this goes in polls by default on a 15-minute interval. So in 15 minutes time what will happen is we'll go out and collect all of this information. So if I just come back to Object Explorer for a second here, what you'll see in Object Explorer, if I expand SQL Server Agent, if I expand jobs, you'll see that I've created a number of jobs. So these jobs are responsible for collecting and then loading the information. So what you'll see here is I've got my collect, I've got collect and unload, all of these different jobs. The other thing that you'll notice if I expand management and I then go to data collection, under data collection what you'll see is that I've now got a new data collection stat, and that's my utility information there. So what I'm going to do now is I'm just going to go and run my job. So I've actually created a SQL agent job here. Now this SQL agent job is designed to then just go and run and force the collection of all of the information. So I'm just going to force that data load now. That way you don't have to wait 15 minutes for this to refresh. Okay, all well and good. But before we wait for the refresh there and just do a refresh, what I also want to do is I want to go and enroll another instance. So I've got my utility control point, but I also then want to go and grab another instance inside of my topology. So in order to do that, I come back to my UCP. I then walk through the wizard process, or alternatively, another way that I can get to that is I can right-click on Managed Instances and I can enroll an instance. Because the other thing that you'll see in this screen here for Managed Instances is you'll see that I've got a traffic light for each of them. So you'll see based on CPU, computer CPU, because remembering we can run multiple SQL Server instances on one machine, so I want to determine what utilization they have out of the entire machine, as well as file and disk space information there. So I'm going to right-click and enroll a new instance. You'll see that's a very similar wizard where I just connect to what is my instance. In this case, it's going to be my, I've got one called R2 named here. Okay. Use my service account and then go and enroll that instance. Now you remember before that I said to you that we could go and customize all of the policies as well. So what you'll see now is I'm going to go into the policy management and to show you how you can customize each of the policies that we have. select Finish. And under my Utility Administration, you'll now see I can configure each of these policies. So I can expand the policy, my data tier apps. You'll see CPU utilization 70%. So only when it gets above 70% do I consider that to be overutilized. I can go and set that. Maybe I just want 50% for this particular one, and then go and apply that. So the next thing that I want to go and show you with my UCP is the ability to now also enroll an application. But before I enroll an application, what I want to show you is the new DAC pack and how we can actually simplify the whole deployment process of moving one database from one server to another. So in other words, how do we easily pick up and transport? So when we identify that the application has caused a problem and that it's overused, this particular application is causing all of the performance issues, I want to be able to pick it up and easily migrate that to another server inside of my topology. So very much the way in virtualization we have a host that has multiple guests on it. We then go and pick up one of those guests and then move it somewhere else inside of the farm. That's what we want to be able to do from a SQL Server perspective. So what I'm going to do is I'm just going to expand databases. When I expand databases, you'll see that I've got Northwind here, everybody's favourite demo database. So I'm going to right click here and you'll see under my tasks, what I'm going to do is I'm going to extract my data tier application. And this is going to take an existing database and create a DAC pack from it. So I'm going to click on Next. You'll see that I can then go and give the application a name. I can then go and add some version numbers in there. I'm going to add some metadata in as well here. So I might call this my sales app. I'm then going to go and pop this somewhere. In this case, what I'm going to do is going to whack that just in my C drive. That way I don't have to look into the bowels there. Click on Next. And what you'll see here is it's going and validating. You'll see one of the things is the login. So it's picking up the login information that I have for the AdventureWorks database and grabbing that from the server level. You'll see that all of the objects are supported here and being scripted out. So what's happening now is it's going and creating this DAC pack. So once we're finished, what will happen is we get this DAC pack file. Inside of this DAC pack file, we'll have 4 files. One of them will be a SQL script, and we'll also have 3 XML files that contain metadata. If I put some dependencies, I get a 4th XML file as well. So let's click on Finish. I'm going to come across to my C drive now, and you'll see that there's my DAC pack. Now you'll see that it's just one file. I can right click on that file and I can unpack the DAC pack. So when I unpack the DAC pack, I'll choose where I want to put that. Oh, that'll do. See Northwind. And what you'll see is there's those 4 files that we spoke about there. Now what I want to show you now is how quickly and easily it is now for me to actually go and make a change or go and deploy. So what I've done is I've extracted this existing database from server 01. I want to move it now to server 02. So the way that I do that is I come back into Management Studio. So what you'll see now is I come into Management. Once I've selected Management, I right click on Data Tier Applications and I select Deployed Data Tier App. So once I've selected Deployed Data Tier App, what I need to do now is just simply go and find my DAC pack file. So I just go and click on Browse, select my C drive, there's my DAC pack. You'll see that it's picked up all of the metadata that I put in there. Click on Next. You'll now see that it's doing the validation. At this point of the validation, it's determining, look, is the target platform that I'm pushing this to, are there any restrictions inside of my DAC pack to prevent that? Now, I haven't taken the role of the DBA away altogether. You'll see that the DBA still gets to choose the name of the database and also where the data file and where the log file will get created for this particular database. So we've still got a little bit of control. You'll see I now click Next. What you'll see now is I've gone inside of my data tier app and I've now gone and registered that data tier app, meaning I can now go and measure the performance of that particular application. But what I've also done is I've also gone and deployed that database. So Northwind has now been deployed directly out of that DAC pack. So what we've shown in that demo is we've shown how do we go and create a UCP, how do we go and utilize the server utility to then go and monitor all of our topology. We've looked at how do we go about extracting our DAC pack or a data tier app, and then how do we then start to monitor that. And what we also showed is how easy it is for us to actually now transport an application from one server to another server. So what we're now going to do is we're now going to go and we're going to pull up the hood. So we're going to go and get a little bit deeper, because what we've looked at is we've looked at the feature down there about our server utility and also our data tier application. But there's a number of changes that have been made in SQL Server 2008 R2 that aren't quite as evident. So what we're going to do is now look at those. So what we're going to do is look at what I think are my top 3. So having worked with R2 for a very long time now, we've had a number of customers that were deployed last year, running on that as part of the TAP program, as well as some of the early adopters. And this is some of the features that we've found that's given really the DBAs a lot of bang for buck. First is Unicode compression. The next is actually how do we go about minimizing our lock key collisions. So in very, very high performance environments, how do we then go and resolve that issue? And also we're going to have a quick look at some of the changes that have been made to the stored procedure that was introduced in 2008 called Estimate Data Compression Savings. Now the first thing we're going to have a look at is we're going to have a look at Unicode compression. Now why is compression important? Well, compression is important because the size of our databases continue to increase in size year on year. We've really got what we would call a data explosion inside of our organisations. Now there's really 2 main drivers around this data explosion. The first is around compliance, because I now need to keep data for longer periods of time, maybe because of regulatory reasons, so SOX or HIPAA, various different protocols that are enforcing the amount of data that I need to keep. But the other thing that's driving this data explosion is BI. Now we all know that BI really just doesn't make a lot of sense. The whole concept of business intelligence in many organisations just is really an oxymoron. So what these organisations want to do is they want to store all this data, because I know that one day I want to report on it. And a great example of this is Walmart. Now Walmart were one of the first organisations to detect what was called the leap year phenomenon. So we all know that in a leap year there's 1 extra day's worth of sales because we've got 1 extra day in the year. But what they identified, that there seemed to be some peculiarity around certain product lines in the 2 weeks leading up to the end of February. So in equivalent, they really had about 12 times the sales that they were expecting. So when they looked a little bit closer, they did some analysis and they worked out there are about 110,000 people in the United States that are born on the 29th of February. Now, if you're born on the 29th of February in the United States, your birth certificate says either the 28th of February or the 1st of March, depending on the time of day that you're born. So as a result, there's this psyche of poor John, poor Jane. They haven't got to celebrate their birthday properly for the last 4 years, so let's buy them extra presents and spoil them. So as a result, sales of cards, wraps, bows, anything associated with gift giving had a huge sales spike. Now, do you think as a retailer you're going to walk down the card aisle and go, that's right, I remember 4 years ago we were out of stock of cards at this exact same time? Of course you're not going to be able to do it. But if they weren't storing this data for more than 4 years, they would never ever been able to see that trend happening there. So that's why we've got this whole concept of data explosion. But one of the challenges in many organisations, especially when they're actually targeting different locales and different languages, is how do I go about storing that information so that that particular language can then go and use that. So for example, I might have customers in Finland, I might have customers in New Zealand, and then I have customers in Australia, because we all know that New Zealand and Australia speak 2 different languages anyway. But the way that I go about doing that is I need to go and store Unicode data. So a great example of that is the word cafe. So cafe has the little accent on top of it. In order to store that accent, I need an additional byte to do that. However, if I'm only using English, the English ANSI characters, so the ANSI 256 characters, actually don't need an additional byte there. So what happens is when I go and store something in SQL Server as an nvarchar or an nchar, what's happening is I'm actually wasting a byte. So what that means is the letter A actually takes 2 bytes to store it, rather than 1 byte. So what Unicode compression does is it extends on the compression that we introduced in SQL 2008 and now allows us to apply this compression both at a row level as well as a page level. And the reason we've got 2 different types of compression mechanisms is because data compresses differently. Now what row level compression does is it goes and takes all of the information on one particular row and effectively turns it into a variable length character set. So for example, if I had a data type that was a big int, do I really need a big int to store the values 1, 2, 3 and 4? Probably not. Only when I get to that ginormous number that I wish my bank account balance was, do I actually need to go and start allocating the number of bytes that's required for a big int. And that's the whole concept of compression at a row level. But we've also got page level compression as well. Because what page level compression does is it takes all of the information on that 8K chunk, because remembering that SQL Server reads and writes in 8K chunks, and it looks for duplicity across that. Slightly more complex than that, but basically, if we think of the phone book, if we get to Smith, do I really need to store all of the instances of Smith that occur on that 8K page or not? Or do I store one and then a pointer to each of them? So the significant performance benefit of this is not only reducing the size of our table, in other words, reducing the size of the MDF on disk, what it also means is for each I/O operation that I perform, I'm retrieving more information. So it might have taken me 2 reads to get the information out of the employees table, but now I can do that potentially in 1 read because of that compression. So let's take a look at how we can go about using compression in R2. So what I've got here is I'm going to actually perform exactly the same demo on 2008 and 2008 R2 to show you the difference between the two. But before we do that, I want to show you this whole concept of Unicode versus non-Unicode. What I'm going to do here is I'm going to use the data length function. The data length function is going to show me how many bytes are allocated for this string. So you'll see that it's a Unicode string because I've got the n in front of it. So what you'll see is when I run this first query, you'll see that it's gone and taken 2 bytes. I run the second query and it's only taken 1 byte. Now this is the whole principle of Unicode compression, is what I'm trying to do here is then go and reduce that down. So there's actually an algorithm that allows us to do that that's being applied. So really only storing the data when we actually do need it. So what I'm going to do here is I'm just going to go and use the dynamic management view in index physical stats. The reason I'm using index physical stats is I want to see what's the average size of each row that I've got in my table. Now, the average size of each row in my table is around about 191 bytes. So what I'm going to do is just show how much space on the disk is actually being used, and you'll see that it's taking up around about 25 kilobytes. 25,000 kilobytes? So what I'm now going to do is I'm going to alter the table and I'm going to enable row level compression. So now alter the table. You'll notice that the syntax is very similar to rebuilding your indexes, where you alter your index. What I'm now going to do is I'm going to run that same query to go and show what the average row size is. And you'll see, remembering that the original average row was about 191 bytes, I've been able to reduce that down now to 100 bytes. So in effect, I've been able to reduce my table by the size of it by 2. But one of the things that I want you to notice as we just go and do an SP help on that table is this particular table has 2 Unicode types in there. If I could type. So what you'll see as I scroll down here is that I've got my sales order number that's nvarchar, and I've also got my carrier tracking number and my customer PO, which is also nvarchar. Now what I want to do now is I want to go and run this exact same test, and I'm going to run it on exactly the same table, but now I'm going to do it on 2008. So what I'm going to do here is just change my connection. Run exactly the same thing. So I want to prove to you that I'm working with the same table. So the original size should be 191 bytes. I'm going to alter the table, row level compression. What I'm now going to do is run exactly the same thing again. And what you'll see here is that the average record size is significantly larger. And the reason that it's significantly larger in 2008 is that we weren't able to go and take advantage of that Unicode compression. Now I'm running this across my fact reseller sales table. It's a fairly small table compared to what we would normally have in the real world. But what we'll find is that just on that, we would reduce our size by around about 2 megabytes, 2008 versus 2008 R2. So significant performance gains that we get simply by using Unicode compression inside of R2. So the next thing that we want to have a look at is we want to have a look at what's called a lock hash key collision. Has anyone ever experienced a lock hash key collision in their databases? Okay. It's a fairly rare phenomenon. And the reason it's fairly rare is that what it is if you cast your mind back to 1996 and 1997, that's when SQL Server 7 was first getting developed. Now this hashing algorithm has not changed since SQL Server 7. It was all the way the same up to 2008. And basically inside of our databases what we've got is we've actually got a logical model that allows us to then go and take a lock. So locks are not necessarily a bad thing because a lock means that we actually maintain the ACID principle, we've actually got integrity around our data. The problem is though is that what can happen is this lock hash is actually calculated by it's a 6-byte value that's calculated. The problem is it's actually possible for that value to get created twice, so we get duplicate values. So what that then means from a SQL Server perspective is we actually go and take a lock out when we actually don't need to it because we've actually generated the same lock hash value. So what we've got now is we've actually rewritten that algorithm in R2 so that we don't have that issue. So what's happening is that it's calculated directly off the B tree. When we had duplicity inside of that B tree, it was then possible that we had locks held for longer periods of time. So what I want to show you is how that works under the covers. So what I'm going to do is I'm just going to connect directly to my 2008 instance because I want you to see how that works in how it works now. So what I'm going to do here is I'm just going to go and create a table called foo in my temp DB. I'm going to have 4 columns creatively named A, B, C and D. I'm then going to create a unique clustered index on 3 of the columns, A, B and C. So once I've done that, what I'm going to do is I'm going to open up a transaction. So I'm just going to do a begin tran. And what I'm going to do is I'm going to insert 4 values into that table called foo. What I'm now going to do is I'm going to look at dmtran locks because dmtran locks is going to allow me to go and see what current locks are on that table. Now what you'll see is that I've got a key lock on here. So what I'm expecting is that that particular record that I'm inserting should have a lock. I shouldn't be affecting anything else in that table, knowing that inside of that table all I've got is one record. So the next operation that I'm going to do is I'm going to perform another insert. Now do you think this insert should be blocked or not? Well, it shouldn't be blocked, no, because I'm actually not, another insert is not doing anything to that particular row, so we don't expect that we're going to have any issue there. But what I want to demonstrate is it's actually possible to regenerate exactly the same key, because what you'll see here, this resource description, is that is our lock key hash that's generated internally in SQL Server. So what happens is there's an internal mechanism. It looks and says, look, do I have any of these existing lock hashes collected? Do they equal? If not, great, I don't adhere that lock to it. Because what we're doing to calculate that is look at the information inside of the B tree and compare that with the data that's being inserted. But what I'm going to do is I'm going to grab that another insert statement. What I want you to notice about this insert statement is it's totally different values. So what I'm going to do is I'm just going to create a new query. I'm going to make sure I'm connected to my 2008 instance. I'm going to execute that. Just change my database context to tempdb and execute. Insert into foo. What have we done here? Is it? I am too. Okay, well that's okay, because what we can do is we can actually go and change that, because what we'll do is we'll do the demo the opposite way around, because what I'll show you is I'll run it in 2008 R2, showing that there is no issue when I change my database context correctly. No worries at all. So we're able to insert that without a problem. So this is R2. Let's rewind now and let's come back to 2008 and see how that behavior works in 2008. So I just want to go and change my connection here. Change it to 2008, connect. I'm going to run through and do exactly the same thing. Go and use my good friend tempdb and create that table foo. Begin a tran. Go and have a look at the lock hash that I've generated. Great. Now let's come back to our other query here now, and let's go and change our connection. We are connected now to 2008. Now when I What have I done wrong there? Okay, cool. So what you'll see here is we've now actually got a block. And that's just going to sit there. And the reason it's going to sit there is because I open the transaction. And the reason I open that transaction is to simulate what would potentially happen when we've got a long-running transaction. Because if we now come back to our other query here, if we were to then go and run an SP-who2, we're then going to be able to go and see, okay, we're being blocked. So this particular process here is currently in suspend. We actually haven't even done anything because there's been no CPU time. The head of the blocking chain is 54, and surprise, surprise, this connection here is 54. So what we've done inside of R2 is rewritten that algorithm so that we don't have that issue anymore with lock hash key collisions. So what I'm going to do now is just going to roll that transaction back. Great. And I'll actually also, before I do that, I'll just change my connection and roll that back as well. So the next thing that we want to have a look at is we want to have a look at the changes to be made to the stored proc SP estimate database compression savings. Because what this stored proc does, it was introduced in SQL 2000 because what it allowed us to do is go and take a look at a table, run it, and then determine what space savings am I going to get as a result of implementing compression. What that allowed me to do is just determine whether row level compression or whether page level compression was going to give me a more effective compression mechanism, or if I was going to get any compression at all. Because remembering that certain data will actually compress better than other data, especially when we've got duplicity. The problem is with this stored proc though, is when we actually compress an object, we do two things to it. The first thing we do is we actually defragment. In other words, we rebuild the indexes on that. The second is we actually apply the compression. Now what would happen often is we would think, great, we're going to get these huge space savings by implementing compression, but often where the big space savings were was not actually the compression, but the fact that we simply reorged the index. Because when we reorged the index, we would then release free space back, and then potentially it wasn't giving us the true result of that. So what we might have found is that we didn't need to compress at all, we just simply needed to rebuild the index. So in R2, we actually now are able to easily go and see what that impact of each of those different components would be. So what's the impact of compression versus what's the impact of fragmentation? So we can then make a decision that's informed about which option do I use. So what we'll do is we're just going to jump into another demo here. First I'm going to run it against R2. What I'm going to do is go and use my good friend foo again. What I'm going to do is this time I'm going to just have 3 columns A, B and C and create a clustered index on A. What I now want to do is I want to just spin through 10,000 times and I want to just put 3 records in there. I want to put in the number, I want to put in the word hello, and I want to replicate 1 300 times. So in other words, 300 ones on each row. So if I now go and select that information, you'll see what I have. So you see, each number, an identity, an effect, hello, and then 300 ones. What I'm going to do is I'm going to have a look at my good friend index physical stats. Index physical stats is going to allow me to go and see what the average record size is. So the average record size here is 417 bytes. But what I'm now going to do is I'm going to run an update statement. So you'll see how much space we're using. So 4296 KB. But what I'm going to do is I'm going to run an update statement. So rather than having 300 ones, I'm now going to have 50 ones. So you'll see what I've done is when I go and select from that. Okay, so we've now got 50 rather than 300 that we had before. But what I want you to remember is that my space used was 4296 kilobytes. Now obviously I don't need 4296 kilobytes anymore because I've reduced the amount of space that's being used. Because rather than storing 300 ones by 10,000, I'm storing 50 ones by 10,000. So let's execute this and you'll see that my space hasn't changed at all. So I'm still using the same amount of space because once I allocate it, I don't go and deallocate it until I go and reorg the indexes. So what I'm now going to do is I'm going to run compression savings. So you'll see that I'm going to run it on the object foo, and what that allows me to then go and see is what space savings I could potentially make. So what you'll see here is we break that down, and you can actually see how much savings I could potentially make. So now when I go and execute this and see this, what you'll see is I'm just going to go and alter my index on there and go and run foo. And what you'll see is that we've got that pretty close to that number, because remembering that it's still just an estimate that it's going to run. So what it said to me is, look, I'm actually going to get all of my compression savings simply by rebuilding the index, not by going and compressing the information that's stored in there. So that's what we've gone and done there. If I was to come back now and do exactly the same thing with 2008 rather than R2, what you'll see is that we don't get that breakdown in information. So we'll just start at the top again. We're going to create our table called foo. We're then going to go and insert 10,000 records in there. Looks like I've still got an open transaction there, so let's just go and close. No. Still got an open transaction. Okay, so we've got to insert our 10,000 records. Just to show you. Same size, 2008 by 2008 R2, but what I'm going to do is just going to run that replicate command. Then what I want to do is run the estimate data compression savings. And what you'll see is that we don't go and get that breakdown. So we can't go and determine, was it the reorg that was going to give us the performance benefit, or was it the compression? So just a more granular way of looking to see where we're going to get our benefit. Because one of the things to remember with compression is we apply compression on a table-by-table basis. So it's not done at the database, it's done at each individual object. So we want to make sure that we're actually going to get some benefit by implementing it. So what are the key takeaways from today's presentation? Well, really what we've introduced in R2 for the DBA is we've gone and introduced our utility control point in our server utility. What that allows us to do is then go and get a unified view of all of our SQL Server instances. It allows us to see our CPU utilization, when something's overutilized, when something's underutilized, and also allows us to get capacity planning information on our I/O performance. We've seen that by using our DAC pack, we've now got very simplified deployment. It allows us to go and encapsulate objects that are external to the database and move them easily from server 1 to server 2. And finally, we've looked at how some of the improvements under the covers have meant that we now get scalability for all workloads inside of R2. So that really brings me to where I wanted to get to this afternoon with this presentation. So folks, I'm going to open up the floor to questions if everybody's got any questions. But once again, make sure you fill out your evaluation forms. And once again, guys, I hope you enjoy a nice beer tonight. The question was, what candidates are not good? What tables aren't good candidates for compression? Well, the first thing, if you're using row compression, or if you're actually not using any variable length data types there, or fixed length data types. If you're using fixed length data types, then you can get some compression savings. If you're using all variable length, then only the space allocated will already be allocated there. If you're using page level compression, then a table that's a good candidate is wherever we've got duplicity. So we've got multiple things. So, 20 centimeter widgets, 15 centimeter widgets, 16 centimeter widgets. Do we really need to keep all of the names of widgets? Probably not. So they're the two tables. So where we've actually already got a lot of fixed length data types, or where we've actually got duplicity inside of our table. So the question is can the UCP be used in the server utility to actually monitor non-R2 instances? Unfortunately, it will only monitor R2 instances at this stage. The other dependency to be aware of is Enterprise Edition will only support up to 25 managed SQL instances. If I want to manage any more than 25, I need to then go to Data Center Edition, which is the new SKU that's above Enterprise Edition. At the moment, the server utility is simply designed to provide that central dashboard around that. All of that data is being collected inside of the management data warehouse, so you could actually then write your own traps over the top of that. Yeah. Mm-hmm. So the question is I demonstrated how do I actually take it from server 1 to server 2. Can we go and change the deltas? Yes, we can. The way that we need to use that is with Visual Studio 2010. Visual Studio 2010 now has data tier application awareness. That allows us to then go and point in the existing, the same way that we'd go and use DataDo to go and do schema compare and things like that. So it allows us to generate the deltas between an existing database and a new database. The question was, can the source for a DAC pack be anything else other than an R2 server? At the moment, it's only supported in R2, so that's our only deployment mechanism is directly to R2 for DAC pack at this point in time.
Is there any performance impact from selecting from compressed rows or tables?
Okay. The question was, is there any performance impact from selecting from a compressed row or table? I'm going to put my consultant's hat on and I'm going to say it depends. Because once it's compressed, the performance impact is negligible. However, if that object is being compressed and I'm selecting from it, there's going to be a performance overhead, and that overhead's typically at CPU. Because any time we talk about either compression or encryption, there's going to be a CPU overhead associated with that. But at the end of the day, typically our SQL Server boxes are actually I/O or memory bound, not CPU bound. So folks, I'm going to pack up here now, but if anybody's got any further questions, feel free to hang back and ask me some questions, or otherwise I'll be outside afterwards. So once again, thanks guys.